Okay, today's lecture will be continuing uh, the last time we learned about the inverse of matrix, right? And we will focus more on the next sections, which is we call the Crammers Rule. I will let you know later. Okay, and I have seen some of your homework. I think it's okay. You did a good job, most of all. I will uh, grade your homework later on this week. And I would like to know um, how many of you still outside of Taiwan? Is there? Okay, Scarlett. Any? I think the other already here. Yeah. So Scarlett, when will you arrive? Have you booked a flight yet? Okay, so is there any estimation when will you come? Oh, okay. Okay. All right. Okay, so you won't go to Taiwan this semester. Okay. So that means I need to reevaluate um, some of uh, because I thought that everyone will come and we will have some sessions in class, basic math and also the other course as well. So if this is the case, then I need to change some parts of our evaluations. And of course, you will need to have some time for online exam. Okay, so that will be the case. Okay. Okay, since everyone here besides Scarlett already in Taiwan, I would like to just continue our lecture and our plan. Oh, okay. So Scarlett, whenever you maybe have some conclusion with Lydia, please let me know. Okay, what will be the consequences? I mean, if you would need to take absence for maybe a year, 1 year, right? Tell me when you will talk to Lydia and tell me the results. Okay, so I will have you to. Okay, okay. Please let me know. Okay, all right. Let me just continue a little bit about the lecture. So last time we did this, right? 3 by 3 matrix. The idea is this is the matrix, okay, the matrix A. So we are going to put this and then take this in row echelon form, and then we make the left part to be 1 1 1 0 0 0 0 0 0, and the right part here will be our inverse. Okay, that's how we are going to have a 3 by 3 matrix and finding its inverse. Okay, I'll wait for a moment. Okay. Okay. Since Maria, you just come in, I would like to know whether you are um, available this semester. I mean, arrive in Taiwan. Are you in Taiwan right now, Maria, or not yet? Or will you come to Taiwan this semester? Okay, please let me know when you are arrive in Taiwan, and we can arrange sometimes to evaluate the exam. Okay, anyway, let's continue to the next sections. This is more about the we call this is the determinants and Crammers Rule. Okay, we already mentioned the determinant. So we start by 2 by 2 matrix. This is we already arrive at this conclusions. Okay, let me write if A usually the determinant we can write it's like an absolute value like this, or we can just write in terms of this matrix like this. It's different from the how we write the matrix, right? And this is equal to AD minus BC. Okay, that's how we are going to calculate the determinants. And usually the determinant on the matrix, we are going to use it for finding the inverse, usually. Okay, so for example, if let's say B, so determinant of B okay, Maria, I would like to know, will you come to Taiwan this semester? Okay. Now determinant B, or we write B, and then we can write this as 6 multiplied by 3 minus 3 multiplied by 2. So this is 18 plus 6. This is 24. So that's the determinant. Yeah, I think I already told you like last month that in the middle of December, you will be difficult to book any of either flight ticket or quarantine hotel because of the policy that the middle of December, everyone outside of Taiwan will be banned from coming inside because of Chinese New Year. I already told you, I think last month, I think last 2 months, I think, because the government already mentioned like maybe from, I think from September. They already mentioned from September, and I already mentioned like in October to get a ticket as soon as possible. Okay. And do you think that you will take some temporary leave? Because it's already near the end of the semester, and I'm not sure. Um, you can discuss with your family, or you can discuss with Lydia from the registrar office. Okay, because I'm not sure the other course will allow you to continue or give you some examinations. I'm not sure, but for me, if you still to continue, I will prepare maybe online exam, but of course it will be different from other students. Okay, okay, I think that that will be the case. Okay, so yeah, every time make announcement, please take some notes. And every time maybe Irene also reminds students, please also keep in mind, okay, because um, yeah, that is important for you. Okay, yeah, please let me know, or if you want to like send me an email what's the situations, and maybe what is the result after you consult with Lydia or with the your family about the situations. Okay. Okay, now continue to determinant. Okay. Yeah, that's correct, Scarlett. Yeah. So Maria, you can consider that as your yeah uh, considerations, that if you take leave before the end of the year, then you can restart next year. Yeah, and please let me know what's the your results. Okay. Okay. Yeah. Please talk to Lydia. Okay. Okay. This is the 2 by 2 matrix. If we have the determinant, okay, let me continue. Determinant of n by n matrix. Okay, so it can be 3 by 3, 4 by 4, 5 by 5. Okay. Okay. Let A be n by n matrix. Okay. The minor of element is the determinant of matrix obtained by deleting the row and the column. So you can choose which row and column of A. And the covector of element is probably it sounds confusing and complicated, but it is easy actually. Okay, example. Let's say we have a matrix. Okay, we have a matrix. The minor, let's say the minor M, let's say a row 1 and column 2. Row 1 and column 2 this is row 1, this is column 2. Okay. So we are only seeing the 0, -2, 4, and 6. Okay. So the minor will be 0, -2, 4, 6. And we can compute this 0 minus -2, 4, or this will be 8. Okay. So the cofactor is -1, 1 plus 2, and then M 1, 2. This is -8. Okay. And similarly, if you look at 3, 3, okay, 3, 3, let me write with a different color, maybe green. 3, 3, row 3 is here, row 3. Column 3 is here. Okay. So the minor will be 2, 0, 3, 2, or this will be 4. So the covector 8, 3t is -1. The 3 plus 3. This is M3, 3. And this will be positive, so this is just 4. Okay. And in 3 by 3, if you look at how the design for the cofactor is actually just plus or minus signs. Okay, so if you look closely, you will see that in matrix 3 by 3, the cofactor should be plus, negative, plus, negative, plus, negative, plus, negative, plus. Okay, now from this minor and cofactor, we can find the determinant. Okay, we can find the determinant. Okay, let me write in the next page. Okay, maybe wait for some time for you to take some notes if you want, or read some important points from here. And I think it's not too different from what you have learned in high school. A minor cofactor, I think, is still the same terminology, same terms. Okay, now let's continue. So to determine the determinant, so let me write determinant of A can be obtained by multiplying each element of the first row by its covector, and then adding the results. And let's say this determinant A, or determinant A like that. Okay. Now this is a matrix n by n, and the determinant will be, we need to add A11 multiplied by the covector and plus A12 multiplied with the covector and plus until so we are multiplying on only the first row if this is the case. Okay. Well, later you will see that if you do the same thing with the second row, third row, fourth row, and if you have more than any rows that you want, as long as it is still in line, you will get the same results. Let me just show you later. Okay. So if you have the determinant 3 by 3, so if you have A, let's say we have 2, 0, 3, 2, 5, negative 1, 4, 6. Okay. Then the determinant A, we can write. Okay, let me mark this first row with a different color. Okay. Now the idea will be, okay, when you have 2 here, okay, let me make different color. When we have 2, okay, we need to delete the row, delete the column, okay, and we write this as 2, okay, and then write the determinant 2, 4, 5, 6, okay, and then plus, but because this is in this covector is negative, so we write, so this is maybe I will write in different color. So this is plus negative plus negative plus negative plus negative plus. Okay. So we minus 3, and then we start looking at this. So we are going to write the determinant as 0, 4, negative 2, 6. Okay. And then plus, but this is negative 1, so it's still negative 1. And then this is 1. Let me write 1 like that. 1 will be 0, 2, negative 2, 5. Okay, each we can compute, okay, like like a 2 by 2 determinant. So we will get, let me write one by one in the process. So 12 minus 20, this is 3, 0 minus 8, okay. This is minus 0 minus 4. So we will have, this is negative 8, negative 16, negative 24. This is plus negative 4. So we will have negative 44. That's how we are going to evaluate the 3 by 3 matrix. Now, this is, we are using the first row, right, to find the determinant A. Now, let's try a different way. Let's try the second row, and then let's try the maybe third column. Yeah, third column. Let me show you here, maybe here. So let's find alternative way to find this determinant. Let me write 2, 3, negative 1, and let me write in different color for the second row, 0, 2, 4, negative 2, 5, 6. Okay, now we are focused on the second row. So we are going to first look at this. Okay, this will be result in 0, and you have the determinant 3. Let me write first. Okay, but you know that if you have this 0, it's easy, right? Because it will be simplified the calculations, because this determinant will be 0, right? The second one you have from here. Okay, and you know that this is, let me write, this is positive, negative, positive, negative, positive, negative, positive. This is the cofactor. So plus 2. And then this will be 2, negative 1, negative 2, 6. And then negative 4. 2, 3, negative 2, 5. This will be 0, and this will be plus 2. 12 minus is minus 1 minus 2 is 2. Okay, and minus 4. 10 minus, this is minus 6. And we will get 10, 20 minus 60, 64. So minus 64. It's the same, negative 44. The same results. Okay. So in any row, the first row, second row, and if you want to try the third row, the answer will be the same, negative 44. As long as you remember these signs here. Okay. Sometimes, mostly the mistake came from this cofactor here. You forgot to multiply with the positive or negative signs. Okay. Let's say the last one. Let's try the last one. Let's try the column. Now the column. Let's try the column. Let's try the third column. So let me write 2, 0, negative 2, 3, 2, 5, and let me write in different color for the third column, negative 1, 4, 6. Okay, so now we get this. Okay, first one here. And remember also to check the covector. So always checking the covector like that. So this will be negative 1. Okay, and then this is 0, 2, negative 2, 5. And then minus 4. Okay, 2, 3, -2, 5. Okay. And then plus 6, 2, 3, 0, 2. This will be -1, 0, minus 4, plus 4, minus 4, 10, plus 6, plus 6, 4. Okay. Now this will be -4, -64, plus 24. So this is 60, 40, 64, 24 become 40, plus 4 is 44. So -44. Again, it's the same results. Okay. So you can choose which one you are going to evaluate. And my idea and my advice for you, if you look at this second row here, okay, you notice that because it has 0, then if you use that 0 as your determinant calculations, like for example here, this will simplify your calculation, and it will make, because it will make 0 here. Okay, so that will be a better choice, I think. Okay, but still remember to write the covector here. Okay, the covector plus minus the signs. Okay, plus minus plus minus. Okay. Okay, and now what is the determinant used for? The first one is to know whether the matrix has an inverse or not. Okay, let me show you in another page. So if A is a square matrix, then A has inverse if and only if determinant A is not equal 0. Okay, because if you see from the, at least from the 2x2 matrix, okay, remember that in 2x2 matrix, determinant A is AD minus BC, right? And remember that the inverse is 1 divided by determinant A, and this will be D A minus B minus C. Okay. And because of this, 1 over determinant A, that the determinant should not be equal to 0. Okay. Okay. Now we will have then the sections called the row and column transformations of determinant. Okay. Do you want to take notes from here first, or no, or just continue? I think continue, right? Just continue. Okay. 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 Wait. QR code here. Okay. Let me wait. Okay, this row and column is sometimes is necessary for simplifications. Okay, so for example, if you have matrix A, okay, is a square matrix. Okay, square matrix means n by n matrix. It can be 2 by 2, 3 by 3, 4 by 4. Okay, at least having the size of row and column, the same size of row and column. Okay, and if B is obtained from A by adding multiple of one row to another, or multiple of one column to another, then determinant A is equal determinant B. Okay, so what does it mean? Okay, so A is a square matrix. Okay, and you can have B from A. So it's actually from the same source A, B. Okay, so B is obtained by you multiply some row and then subtract or add to change one row or one column. Okay, for example, I think it's easier to explain by example. Let's say A is having 4 by 4, like this. Okay, seems 4 by 4 is complicated, like, right? Okay, now what will we do? Okay, first is to see the numbers. Okay, to see the numbers. This is 8, 3, 24, 2. Okay, and then this is 2, 6. Okay, and you have -4, -12. Okay, if you look at row 1 and row 3. Okay, if you just take closer look, row 1 and row 3. Okay, compare both of these rows. Okay, so you will see that row 1 is 1/3 of row 3, at least, except this one, right? Except this one. Okay, but you will see the other one is at least third times, or 1/1/3, right? Okay, now let me multiply this by 3. Okay, or multiply this by -3. Okay, and then plus this row 3. Okay, so row 3, I will transform row 3 into another line of row. Okay, so I will write A or B. Okay, let me write B is the transformation of A. First row is still the same. I will transform just row 3. Okay, this is 3, 5, -3, 11. So this will be 24, -24. I will write multiply with the negative. This will be -6. This will be +3. This will be +12. And I will plus this 2. Now notice that -24 plus 24 is 0. -6 plus 6 is 0. 3 plus 1 is 4. Okay, and 12, -12, 0. And still we have another one here. Or let me write with a different color, sorry. So 0, 0, 4, 0. Okay. Okay. Right? Okay. And we expand, if we expand this, okay, and we find this to find the determinant, we can do that. And by using 4, right? And we can write this determinant. Actually, because we have the row and row column transformation. So determinant A will be determinant B, and it's equal 4. Let me write the covector. Don't forget the covector. Okay. So 4. Now we have 3 by 3 matrix. Okay. Okay. Let me move this a little bit higher, maybe around here. Or maybe let me take this a little bit smaller. Let me make here, resize a little bit. Okay. Now again, if we look at this 3 by 3, the 3 by 3 matrix, okay, look at first, let me write this row 1 and row 3 like that. Okay. Look at row 1 and compare with row 3. We can take this 8 and 2 and make it some simplifications. Okay. Okay. Or we can see, I think better just to see the column. We can also try the column C1, C2, C3. Okay. Column 1, 2, and 3. I think better using the column here. So if you look here, 8 and -4, 2 and -1, we will see that this is actually at least twice, right? Twice. So if we are going to multiply with it twice here, let me write this as multiplied by 2. This will be resulted with -8, 22, and this will be -2. And plus this C1 and C and 2 C3. So C1 plus 2 C3. So we will have 4, 8 minus 8, 0, 3 plus 22, 25, 2 minus 2 is 0, 2, 5, 2, -4, 11, -1. So this row and column transformation is something that you can do in every square matrix to simplify the calculations and simplify the process. And by looking at this, now we can simplify the process and take this as your computations for the minors and covectors. Okay. So we will have 4, and then this is, let me write in different color. This is positive, negative, positive, negative, positive, negative. So this is negative. So we'll have -25, and then determinant is, okay, I think this will be simple compared with the previous calculation we did. This is negative 100. This is negative 2, negative 4, and negative 2. So this will be result with plus 8, 8 minus 2, 6, 6, negative 600. This will be, so determinant of A is negative 600. So if we have this results, then if the question is asking whether it has an inverse or not, then the answer is the A has an inverse. Okay. Okay. Any questions? Any questions? Okay. I think row and column. You can transform the row and column, okay, based on multiplications, and then you add or you subtract. Also fine. There is no restrictions for the transformation, as long as the matrix is a square matrix. Okay. Okay, let me check what else do we have. Okay. All right. Any questions? Any questions? I will maybe wait for a few minutes for you to think from here. If you have any questions, you can write down in the chat box. Okay. Now let me continue. Okay, let me continue with one other method to find solutions for a linear equations. It's called the Crammer's Rule. Okay, let's say we have ax plus by equal r, and we have cx plus dy equal s. Okay. This is to solve linear equations. Okay, Crammer's Rule. Okay, first, if we want to solve this, let's say we are doing the eliminations. Okay, let's try doing the eliminations. Okay, I will multiply the first one with d, all with d, and the second one I will multiply all with b. Okay. So I will write this is A, D, and X. Maybe I will write X like that. And then B, D, and Y. Oh, not D, BD, sorry. D, oh yeah, correct. D, B, okay. And this will be CB, BD, okay. The idea is to have this BY and DY eliminating each other. So we need to multiply with D and B. Okay. Well, you can also try to eliminate AX and CX, but I will try from this BY and DY first. Okay. This will be RD and BS. Okay. Now let's subtract this so that I can cancel this, right? Okay. And I will have ADX, maybe different color. So AD X, okay, minus CB and X. And this will be RD minus BS. Okay. We can find that X is RD minus BS divided by AD minus CB. And similarly, if you want to eliminate X, you will find Y. If it will be equal AS minus CR divide AD minus BC. Oh, this is BC. Okay, if you look here, maybe I will write, if you want to have the AX and CX eliminated, this will be resulted with ACX, AC. So I need to multiply with C, BC, ACX plus AD. And this will be SA. So this will be, cancel this. This will be Y equal RC minus SA divided BC minus AD, or we can convert this and take this, the switch becomes AS minus CR and BC, AD minus BC. Okay. Why? Because we would like to see that this AD minus BC is perfectly similar, right? Okay. Okay. So from here, actually, we can find that, or we can express the solutions in terms of, so if you have the linear system, AX plus BY equal R, and this will be having CX plus DY equal with S, okay? And this is have this solution has the solution x will be x will be this. Okay, look at here, RD minus PS. It's this. It's the determinant, right? And y will be okay, and it needs to be provided that the determinant of A, B, C, D is not equal to 0. Okay. Now we have this. So this is called Crammer's rule for two variables. Okay, so for two variables x, y. So what you are going to do here is you change the first column with the rs, and for y you change the second column with rs. Okay. Simply we can write this system, okay, as D. Okay, let me explain later. But any question here? Any questions here for the Crammers rule? I think you already got in high school, some of you, right? So we can write this in terms of x is determinant x like that, and this is determinant of whole functions or whole system, and y is determinant y, and divided by determinant. This means that need to replace first column by R and S. This means replace second column by R and S. And D means the determinant. Okay, the determinant. Okay, let me give you an example. Okay, let me give you an example. I have the system. Okay, now we have this and solve the system. So what it means is you need to find x is what solution of x and y is what solutions. So first, if we are going to find the determinant of the system, we can find D. This is from 2, 6, 1, 8. This will be 10. Okay, and you can find the x. You exchange with the -1 and 2. So this will be, let me write a different color. This will be -8, -16. Oh, sorry, -6 and 2, -12. This is -20. And let me write the other one. This is 4 plus is 5. So x is negative 20 over 10 is negative 2. Y is 5 divided by 10 is half. So this will be the answer. So Crammer's rule depends on, I think, on the situation. It might be your best choice to solve the system. Okay. And Crammer's rule, it can be applied to more than two variables system. Okay. So let me write some notes. Okay, notes for Crammer's rule. Crammer's rule can be applied to any system of n and linear equations in n variables, in which the determinant of the coefficient matrix is not 0. Okay, so we have, for example, the matrix A11, A12, okay. So if a system of n linear equations in n variables, or let me take this into n, like this, into n variables. N variables like x1, x2, xn is equivalent to the matrix equation dx equal 8, equal b. This is the d, x, and b. Okay? And if d, okay, the determinant d is not equal 0, then the solution are, let me write with blue, x1, d x1, d x2, d x2, and xn. Okay. Where dxi is matrix obtained by replacing the column of matrix D by N by 1 matrix B. Okay. So the idea is still similar. Okay. So either you have just 2 variables to solve or more than 2, like 3, 4, 5, 6. The idea is still same. You just need to replace the column with the, like here. You need to replace the column in D with the matrix B. So for example, you need to replace this one, replace with this B. Okay, that's the idea, and it depends also how many solutions we have, how many N we have, right? Okay, let's just give you an idea and an example on how we are going to use this. Okay, I believe this is quite practical and you can try right away. Okay, let's try the Crammers Rule. Okay, let's have this 2x minus 3y plus 4z equal 1. X plus 6z equals 0. 3x. Okay, let's try this. First, we have our d. This is, we have from 2, -3, 4, and then 1, 0, and 6, 3, and then -2 and 0. Okay, now we can take the solution from here. We take the determinant, evaluate the determinant. We can choose the row 2 or column 3 if you want, and then you write the factors, the cofactors. Okay, now we have, let's try to I think from -1 here, I will use the row 2. And then the 0, okay, and then -6. 2, -3, 3, -2. And let's check. 0, 0 minus 8, so plus 8, minus 6, -4, negative, it will be plus 9. So this will be -8. This will be -8. This will be 5, 6, -36, -30. So this will be -38. Okay. That will be the determinant. Okay. Now we can also find the other element that we are going to need for the Crammers. So let's check the dx. Okay, we are going to exchange x with 105. So let me write 105. This will be -2, 0, -2, and this will be nicely done. Okay, and if you look here, we are having really nice calculation here at the row 2, right? So let's just use that. So we can have the determinant is, check the, again, don't forget the cofactor, just to make sure that we are correct. So -6, 1, -3, 5, -2. So this will be 6, -2, minus minus, so it will be plus 15. So it will be 13, 6. It will be 78, -78. Okay. And the same way, we are going to find dy. We are going to have, this is 2, 1, 3. And this will be 105. And 4, 6, 0. Okay, I think we can also still using the row 2. So this will be positive, negative, positive, negative, positive, negative. So this will be row 2 is 1, -1. And then 1, 4, 5, 0. And then -6. This will be 2, 1, 3, 5. So -1, 0, -20, -6, 10, -3. So 20 and -42. This is -22. Okay. And another one is dz. And change the last part with 105. And again, we can see clearly that the row 2 is better choice for us, right? Because of this, because of 0, 0. So we are going to evaluate this -1, -1, and then -3, 1, 2, 5, and the other will be 0. So this is -1, -15, -2, so +2. So this will be 13. So we get that our x is -78 over -38. Or this is what? 39, 19. Yeah, we can take another steps, and that's our x. This is -22, -38. This will be 11 over 19. And z will be 13 divided by -38. It's just this. Okay, so this will be our solutions. Okay. Okay, that's the Crammer's rule. Okay, any questions so far? Previous page, which one? This one? This or before this? This one? Which one, Ardian? After this one? The Crammer's rule here? Okay. Okay, so Crammer's rule is actually a system that came from our understanding in solving the linear equations. Okay, so when we eliminate the system, like in this case here, the first example here, how do we define our Crammers rule? We are using eliminations, right? And then we have some solutions, and based on that solutions, we can relate with the metric system, okay? And we can exchange the metric system, and exactly the solutions are the determinant itself, okay? And this is for two variables, and in the n variables, we will also observe that we also observe that in n variables, the Crammers rule also can be used for to uh, to check the solutions of the system. And of course, the determinant, the d, should be provided, should be exist. Okay, if it is resulted in 0, then we cannot use the Crammers rule. Okay, so far we already take some time to learn the inverse. Okay, the determinant. Okay, and then how to find the determinant by 2 by 2 matrix, 3 by 3 matrix, and more than 3 by 3. As long as it is a square matrix, we can find the determinant, and we can use the determinant also for finding the solutions directly by a Crammers rule, Okay. Now the last sections in this determinant and Crammers rule is this is about the area of a triangle. Okay. Okay. Let's say we have a triangle with a point A1, B1, A2, B2, A3, B3. And let's say we have this area here. Okay. If the triangle in coordinate plane has vertices A1, B1, A2, B2, and A3, B3, then the area of triangle is equal, this area is equal, plus minus half, and then determinant of A1, A2, A3, B1, B2, B3, 1, 1, 1. And then the sign here, it says that it is plus or minus. So the sign is plus or minus, and it will be chosen to make area positive. Do we have time? I think we have time. Okay. Okay. There is some questions, I think. Okay. How to have this in our formula? Okay. How do we prove this? I think I can have. Maybe I will give you some idea. Okay. Maybe later I will prove this later. Maybe tomorrow class. Okay. So that we can have more time to prove the triangle. Let me give you some. Okay. Okay. Let's try some example. Okay. Let's try some example. Okay. Some example. Maybe I give you three or two or three example. Okay. Let's say we have negative 2a plus c is 2, and we have a plus 2b minus c is 9, and 3a plus 5b plus 2c is 22. Solve the system, find a, b, and c. I think whatever method you choose, you can find. But please try first and let me know the results. Okay, for a, b, and also c. If you remember the Gaussian eliminations, you can do with that method too, or you can do with other as well. If you want to use the Gaussian method, this is the way you need to write. And the idea is to have this 1, 1, 1, and the other is 0. This is part here 0, 0, 0. Okay, let me give you a couple minutes, maybe 3 to 4. Check. Anyone fine? Okay, negative 1, 5. Okay, 0. All right. Okay, good. Negative 1, 5, 0. Okay. Which method you are using, Scarlett? Okay, Gaussian. Okay. Okay, because you tried Gaussians, let me try the determinant method for the Crammers rule. Okay, let me write the determinant will be negative 2, 0, 1, 1, 2, negative 1, 3, 5, 2. Okay. Now I will look on row 1 and I will take this finding the determinants. So this will be 2, 5, negative 1, 2, 0, and then 1 plus 1 plus 1, 1, 2, 3, 5. This is negative 2, 4, negative, negative, so it's plus 5. Plus 1, 5 minus 6. So 4 plus 5, negative 18, negative 1, negative 19. So let's try to change this. Change into 2, 9, 22. Okay. So 0, 2, 5, 1, negative 1, 2. Still the first row I will use. Negative 2. Oh, come positive 2, sorry. Positive 2, it's 2, negative 1, 5, 2. This is plus 1, and then this will be resulted 9 to 22, 5. This is 2, 4 plus 5 plus 1, 45 minus 44. Okay, it's 1, 9, 18 is 19. Okay. It's actually it's not the X, sorry, it's A, right? The variable is A. Okay, so yeah, let me just use the I think I can use the third row because I like 22 to be outside. So 3, and then negative 22. And then plus 2. Okay, this will be, let me write here. 3 is negative 18, negative 2, negative 22, 2 minus 1 plus 2, negative 18 minus 2. Oh, I think this is wrong here. Sorry. This should be 2, 9, 1, negative 1. So this is negative 2, negative 9. Okay, that's correct. 3, negative 33. This is negative 22. This will be negative 20, negative 40. Wow. 5, 5, negative 95. Okay. The last one here is 2, 3, 0 to 5. And this will be 2, 9, 22. I will stick with the first row. This is 44 minus 45 plus 2, 5 minus 6. Negative 2, this is 2 plus 2 minus 2, or 0. Yeah. Okay, so x will be 19 divided by negative 19. This is negative 1. Y will be negative 95 divided by negative 19. This is 5. And sorry, it's not x, y. It should be a. And c will be 0 or 0. So a, b, c is, a is negative 1, b is 5, and c is 0. Okay, that's the example. Okay, I think we can just go to our feedback. So prepare your paper, because I think there will be some calculation we will do. Let me give you sometimes 1-2 minutes to write notes if you want, and maybe if you have any questions, you can write your question before we go to the feedback time. Okay, I think we can go to feedback time. Let me stop the presentation. Please join the feedback. Okay. And maybe you can write your student ID. Okay. I can see who is joining and who is not. Let me wait for a minute. Okay. Okay, who else joining the feedback? Please write your student ID, okay? The students who are joining now. Okay, let's start. 3, 2, 1. Okay, let's start. Okay, good. Okay, next one. Okay, 3, 2, 1. Need to roughly sketch and find the determinant. Okay, 1 minute. Okay, 20 seconds. Okay. Okay, good. Okay, good. Okay, last question. 3, 2, 1, let's start. Right as mentioned. Okay, as mentioned. So write XYZ, the results, comma, comma, without spaces. Okay. Fifty seconds. Okay, 6, 5. Okay. Okay, but I think without bracket is also correct. Yeah. Okay. Okay, congratulations. Okay, congratulations for the winner. See you tomorrow, guys. We still have some sections on the chapter 10. Okay, hello Kenzie. You just come, right? Okay, wait. Okay, why don't you ask before? Okay, wait for a minute. Okay. 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 Okay, and don't forget, you have, I think Blessing didn't submit your topic. Okay, so I'm not sure which topic you will be on discussing later. Okay, so anyway, that will be the end of the lecture. Uh, so see you next. See you tomorrow. See you tomorrow. Yeah, you're welcome.